everyone, welcome back. I hope that you guys all had a good spring break, I guess. It's kind of felt like we're on summer break a little bit with the amount of time that we've been gone. Does not feel like summer outside though. I am ready for some sunshine. I don't know about you guys, but I miss all of you, and I hope that you guys are enjoying these videos and practicing some math stuff at home. Oh, we have a special guest today. This is Nira, my kitty. She says hello. She just jumped up on my lap. Apparently she wanted to be in the video. So today we are going to be talking about probabilities and finding probabilities and comparing them. So in math, we have two types of probabilities. We have what are called theoretical probabilities. So these are the things that are supposed to happen based off of just general statistics. And then we have actual probabilities. So this is what really ends up occurring when we live out these situations in the real world. And they don't always match up. They will match up if you do it enough. But a lot of times that requires a lot of tests. So today we're going to find probabilities using some more common items that I hope you guys have around your house. So the first one that we're going to be doing is finding theoretical versus actual probabilities of a coin toss. So pause the video, go find a coin somewhere laying around in your house, and let's get to work. Okay? Oh, grab a paper and pencil while you're up getting your coins too, because you're going to need that to be able to record all your information today. All right? Okay, so the first thing that we need to do is we need to figure out what, in theory, should happen if we toss a coin. So what are our options for when we toss a coin? Well, we have heads or tails, right? So we have two options, and of those two options, only one can happen at a time. So our probability of flipping heads is a 1 out of 2 chance. Same with tails, because there isn't anything wrong with my coin that makes me think, oh, well, I might get heads more often than I end up on tails. So I'm going to write down what our theoretical probabilities are, and you do too. So I'm going to make an H and a T for heads and tails. And then we get a 1 out of 2 chance on both of these. So that's how we write our probabilities. We write them as fractions if you didn't know that. So then to make our lives a little bit easier when we go into comparing our theoretical to our actual coin toss outcomes, it's best if we make these into a percent. Oh, and apparently my cat decided to climb up on the shelf back there. She's looking out the window. So there's a couple ways you can do this. 1/2, a lot of you guys have this percent memorized, but this is a easy problem for us to practice this on. And if you'd like today, go ahead and use a calculator, because we're going to be working with some not very friendly numbers. If you want to do it without a calculator, that's completely your choice, but you have my full permission to use a calculator today. So the way that we can figure out how do we turn a fraction into a percent, that's what we're trying to get to today. So to turn a fraction into a percent, you have lots of different options. Now, a common option is to get our denominator and turn it into 100, because, you know, percents are always out of 100. That's what they're calculated from. But all of our options today are not going to be super friendly to getting those numbers to 100. So our second option is to remember the fact that a fraction bar, this little guy here, that means divide. Okay, so I'm just going to divide my two numbers. So in the calculator, I would do 1 divided by 2. That will give me a decimal answer, or it should. So that ends up giving me 0.5. And I think everybody knows that 1/2 as a fraction is 0.5. Then after that, we turn our decimal into a percent. So think for a second, how do I turn my decimal into a percent? We move it over 2 places. So I have to move this over twice. So over 1, 2 times. And I have that blank there. So what do we do when we have a blank? We fill it in with a 0. So most of us probably already knew that 50% was 1/2. We know that usually. So that wasn't too hard. But we're going to get into some not as friendly numbers as we move through this lesson today. So I wanted to practice that with you so you had the ability to do it later on. So in theory, we should get 50% heads, 50% tails. So half the time heads, half the time tails. But we're going to see if that actually ends up happening in our real world situation. So you're going to make another chart, and you'll make a chart for your actual coin tosses versus on another side of your paper. So this is the way mine looks right now. So I've already done some of these, so I don't bore you with a million coin tosses. And you can do as many as you want. The more you do, the closer you're going to get to our theoretical probability. The less you do, the likelihood of you getting 50% is going to be a lot smaller. So I've already done, on this one, I did 16. So I would recommend doing at least 20 for each of these different probabilities that we're doing today. If you want to do more, go for it and see if you can end up with that 50%. But set an amount that you're going to do before you actually get started, because what I don't want you to do is, like right now, I'm at 16 and these are completely even. I don't want you to get to 15, get to a point where it's even and just stop there and say, oh, look, I got to exactly a half. Pick an amount that you're going to flip right now and don't shorten that so that your results match what you think should happen, okay? So I have 16? Yeah, I have 4 more coin tosses to do. So I'm going to do those real quick, and you can do some coin tosses while I'm going. So I got tails, 1, heads, and I'm keeping a tally chart because it's easier to count that way at the end. Ooh. Tails. Okay, moment of truth, last one. Let's see what I get. I am not doing so hot. Tails. Okay, so let's see what my results are. So here's my results. Go ahead and pause the video, finish doing your coin flips, and turn it back on when you are all done collecting your data. So for me, I ended up with 9 heads and 11 tails. So now I'm going to find out what the probability of these, what the actual probabilities, actual percentages I got, okay? So we did 20 coin tosses, or I did 20 coin tosses. So my probability of getting heads was 9 out of 20. I did, for my tails, I got 11. So I would have 11 out of 20. These are my probabilities that I got. Then I would take and turn those into a percent and compare them. So for the 9, this is a 45%. And for the 11, I got 55%. So when I compare my actual to my theoretical, they're pretty close on this particular time. Yours might be completely different than mine, though. Maybe you got 50%. That happens sometimes. But what I want you guys to take away from this is that what we want to have happen, what we want to have happen in math doesn't always happen when we get into the real world, because there's so many factors. Maybe you flipped your coin different each time. The way you threw the coin up in the air. All sorts of different things, okay? So the next one we're going to do is a dice roll. So go around your house, see if you can find a dice. If you don't have a dice, you can use some different options, and we'll talk about those at the end of the video, okay? So with a dice, okay, here's my little dice. You have 6 sides, okay? So my theoretical probabilities are going to be, for rolling a 1, my chances of getting a 1 should be 1 out of 6. My chances for rolling a 2, 2 out of 6. Rolling a 3, 3 out of 6. Oh, hang on, I'm saying things wrong. Each one of these faces of the dice, you have a 1 out of 6 chance of rolling them, okay? So here is how my theoretical probabilities are set up. They're all the exact same. And when I convert these fractions into decimals, so think back to how we did that at the beginning. If you need to rewind and rewatch that, do that. You get 16 And if it's 16.6 repeating, so I'm going to go ahead and just round it up to 17% would be my chances for each and every one of my dice rolls. Okay, so I've already rolled the dice a few times, and I've had some interesting things happen. My chances of getting my numbers are pretty straight across the board, except I haven't rolled a single 4 yet. So I rolled, let's see, 4, 3, 6, 9, 11. I have 4 more dice rolls to roll and see what ends up happening here. So pause the video, roll your dice, do 20 or more rolls, and let's see what you get. Okay, so I'm going to roll 4 more times. I got a 3. That's really loud. I got a 1. I got another 3. And I got a 2. So pause the video, finish up your dice rolls, and then restart when you're ready. So here's my outcomes. I didn't get a single 4 in my 20 rolls. That's crazy. So obviously these theoretical probabilities are not going to line up to my actual probabilities. It might on maybe a number or 2, but probably not, since I didn't get a single 4. So in this case, we did 20 rolls, or how many ever you decided to do. So that's how many each of my numbers are out of. So in the 1 category, I rolled 5. So my probability for getting a 1 would be a 5 out of 20. And so on down the list. So my 2s, 4 out of 20. 5 out of 20. My 4s, 0 out of 20. 3 out of 20 for 5s. And 2 out of 20 for 6s. So when I go ahead and do those probabilities, let's see what happens. So my first one, my probability of rolling a 1 was a 25%. My probability of rolling a 4 was a 20%. My probability of rolling a 5, 25%. My probability of rolling a 4 was a 0%. My probability of rolling a 5 was a 15%. And my probability of rolling a rolling a 6, if you have a dice with a 20 on it, that's cool. That would be 10%. So my actual probabilities on this one did not come anywhere close to theoretical, except maybe on a 2 and a 5. Those are pretty close to a 17%, but way different than what was supposed to happen. Okay, so let's see what happens on yours. All right, the last probability that I am suggesting that you find is a little more fun, and that's going to be with food, because anything involving food is more exciting. So what I want you guys to do is find a colorful food in your house, so an item that you have that is multicolored. So I'm going to use M&Ms, which also I just discovered these fudge brownie M&Ms. If you haven't tried them, they're fantastic. Sorry, parents, but next time your parents go to the store, see if they'll buy them for you. Okay. But you can use like Fruit Loops. If you have, let's see, what's another colored food? Basically any kind of candy, like if you got Sour Patch Kids, things like that. You could also do this with just an assortment of things. So maybe you don't have a bunch of colored food at your house. You could do it and make like your own like trail mix kind of thing. Maybe you have like pretzels and goldfish and some Cheetos and things like that, that you could mix all together and do this experiment with. Or I have, at my house, we take and throw spare change into a jar. So I have a jar that has some spare change in it here, and maybe you have something like that at your house where you could mix up some change and do this experiment that way as well. Okay? So with this one, it's a little more involved. So the first thing you have to do is figure out how many of the items that you have. So I've already done this. I took my bag of M&Ms over here and I counted them up. So I didn't go ahead and count every single M&M, because what I want to know is how many of each type of M&M I have. So I took a little shortcut. So what I did was I counted up how many of each color of M&M I have. So I had 7 blue, 13 green, 19 orange, yellow I had 12, red I had 14, and I had 25 brown. Then I added all those numbers up to see how many M&Ms I had altogether instead of doing 2 steps of counting. This made it a little bit quicker. So here's the math that I did down here on my counting for M&Ms. So I have 90 M&Ms in this bag. So the next thing that you do is you have to figure out what's the theoretical probability of picking those colors. So I've done that. My probabilities were as shown. So it's how many you have. So I had 7 blue, okay, over how many items you have. So my probability of drawing a blue is 7 out of 90 because I have 7 blue M&Ms in the bag and 90 altogether. And then I just did that all the way for every single item, every single color. And then I found my percentages based off of that. So based off of this information, I should be drawing brown a lot more than I should be drawing blue. So let's see if that actually ends up happening, okay? So if you are using food, please make sure you wash your hands because you're going to be digging all around in the food and we don't need all your germs spread around, okay? So I've already done this a little bit. I have done 16 trials, so I have 4 more to do. And when I look at this, I found it kind of interesting because yellow and orange were my highest, and those are not the highest as predicted. But blue is the lowest, and that was what should be happening. But brown, I haven't drawn very many of those, and that is not what I expected to have happen. So when you go to do these drawings, you have to make sure that you don't look. Okay, so my bag, I can't see through it. Reach in and just pull out a color, okay? Once you see what the color is and record it, you need to put it back in the bag. Do not eat it until the experiment is over, okay? So I drew a yellow, so I'm going to mark that on my paper here. And I need to do 3 more. So go ahead and pause the video, take care of all of the math work that you have to do for this particular one, and draw your M&Ms or whatever item you're going to use, and come back when you are done, okay? A green, ooh, a brown, and I got 1 more to draw, orange. All right, now I can eat one. Seriously, guys, they're so good. Buy some. All right, there's my plug for M&Ms. Sponsor me. All right, so now you can figure out what your actual probabilities are. So in this case, on my actual side, I have only drawn 20. So my denominators need to make sure that they're 20, not 90. So that's when making these percentages is really important, so I can compare those instead of the fractions because the fractions are so much different than on my theoretical and my actual side. So on my actual side, blue was 1 out of 20, green was 3 out of 20, orange 5 out of 20, yellow 6 out of 20, red 2 out of 20, and brown 3 out of 20. So when I'm going to go ahead and do my percentages. You guys pause video, come back when your percentages are done, okay? So I got a 5%, 15%, 25%, 30%, 10%, and 15%. So when I look at my actual versus theoretical, some of them are close, but some of them are not close at all. So my blues, those were pretty close. My green was really close. Orange, relatively close. Yellow was very different. Yellow is almost, was almost more than that, twice as likely to get a yellow than predicted. Red was a little bit under, and brown was a lot different too. So I just find these interesting to just see what actually ends up happening. In the real world, things don't work out as nicely, and I know that A lot of times people say they love math because the answer is always the same each time. But when it comes down to it, math in the real world is messy. And that's okay. That's what I like about math, is that it is unique for each and every situation that you go through. So some options on other probabilities you could do around your house. If you have a deck of cards, you could shuffle those up and find the probability of drawing a king, or maybe even the probability of drawing a specific card if you want. Maybe a probability of drawing a suit, so like the clubs, spades, diamonds, can't remember, hearts, or the color. That's a 50-50 as well if you don't have a coin. But you could do this with basically anything that you have, as long as you can have multiple outcomes occur on your when you do your probabilities. So be creative. See if you can come up with something else to do probabilities of. Originally, I had thought of finding the probability of my dog catching a ball, but the odds of that are pretty slim. She's not very coordinated. Or something like that. Maybe play catch with your sibling, you know? So comment on the video. Let me know how your probabilities turned out. And I hope to see you guys again soon.